Hello, 30-1s. Here is our second lesson on division in polynomials. Make sure you've already watched the lesson on long division. Now what we're going to talk about is something known as synthetic division. Remember our goal here when we are dividing. Our goal here is to hopefully find factors of our polynomial so that if we have a factor, then we have ourselves an x-intercept. That's important. So that's why we're doing this. Let's look at the same polynomial we looked at in the last lesson, which was x cubed plus x squared minus 9x minus 9. Okay, we divided this using long division in the last lesson, and we figured out one of the factors is x plus 1. So we're going to divide this by x plus 1 again. But this time I'm going to do something known as synthetic division. Now, some people really like synthetic division. It is a little bit faster than long division, but I don't want you to forget about long division. We really need long division when we start getting into more complicated functions, especially when we're in calculus. But for now in 30-1, you might prefer this. Here's how synthetic division works. Looks like I'm about to do something wrong. I'm going to take our division bar, and I'm actually going to flip it upside down. And then watch what I'm going to do here. I'm going to look at the coefficients of our polynomial p at x, and that's all I'm going to write down here. Just like that. So I'm going to do away with all the variables. And I'm going to divide. So what am I going to divide by? Well, I'm dividing by x plus 1. So in synthetic division, what I'm going to say is, I'm going to set this equal to 0, and I'm going to isolate for x. That's the x value on the polynomial that I'm looking at. So I'm going to put that -1 right there. Now, here's how this goes. First term, I drop down. It's a 1. Then I say to myself, -1 times 1. That's -1. Then I'm going to add these together. 1 plus -1 is 0. And I repeat the step. -1 times 0 is 0. I add these together. -9. I repeat the step. -1 multiplied by -9 is 9. I add these together. I get 0. All right, what do I have? This right here is my remainder. I have a remainder of 0. That tells me x plus 1 is a factor of the polynomial. Okay, wait a minute. What is all of this here then? Guess what? We divided x cubed by x plus 1. So this dropped our polynomial down by a degree. What this is here is 1x squared plus 0x minus 9. Our polynomial, we just factored it. We divided by x plus 1, and we brought it down a level. We dropped it a degree. And now look at what you can do. You can actually, let's rewrite that maybe first as a simpler form. That's a difference of squares. Now you can completely factor the polynomial. Just like that. Okay, so synthetic division definitely works a little differently than long division. I'd like to note I'm using addition method. There is another method for subtraction, but I think addition's easier. Okay, let's try this again. It takes a couple times to get a handle on synthetic division, but once you do, a lot of of students prefer it over long division. Okay, I'm going to divide again. The exact same polynomial. This time I'm going to divide by, oh, I don't know. Let's just keep life easy. Let's say we're going to divide by x minus 2. Let's see what happens. So to set up my synthetic division, it's like you flip your division bar, you write your coefficients down from your polynomial. Then I say, okay, what am I dividing by? It's a point on my curve, so I'm going to isolate for x. So the 2 goes over there. Now, synthetic division, here we go. Take the first term, drop it down. 1. Then I say 2 times 1 is 2. Then I add these two things together. 1 plus 2 is 3. Then I go 2 times 3 is 6. Add them together. Negative 3. 2 times negative 3 is negative 6. Add them together. This is now negative 15. Okay, this is our remainder. What does that tell us about the graph? What it tells us is this is not an x-intercept. This is our remainder. But what it's telling us is it's not a factor because it's not 0. So what we just found out is we just found another point on our curve. This is the point 2, negative 15. Now, what is all this over here then? Well, this is 1x squared plus 3x minus 3. We divided by a degree of 1, so we dropped our polynomial by a degree. Since it's not a factor, we can't write this thing in factored form. It didn't get us towards that goal. But what we can do is we can rewrite our polynomial now. P at x is equal to, well, what did we just do? We just divided this thing. So P at x is equal to x squared plus 3x minus 3. We have a remainder. Well, that means that remainder isn't a factor. So it's minus 15 over, what did we divide by? X minus 2. It's not a very pretty way to write our polynomial, but that's what that is. That's what you just found out. That's your division statement. That's your division statement. So your division statement isn't super important in 30-1, but some people like to talk about it. So what do you have? You've got your remainder over your divisor, and this piece right here, that's called your quotient. Okay, not a big deal, but you never know when these things will come up. So synthetic division is a speedy little way to divide. Some students, like I said, prefer it over long division, but in the grand scheme of things, I'd like you to practice both. When you get to calculus, trust me, long division is going to be the way you're going to want to go. That's it, my friends. Hope that helped.